The following video is on implicit differentiation. We'll start by talking about what an implicit function is. We're used to looking at explicit functions. Those are functions that can be written in the form of y equals f of x. So functions like y equals x squared, where all of the x's are on one side and the y is on the other side. Another option would be f of x equals sine squared x minus 3x. And once again, the f of x is acting as the y here, so all of the x's are on one side and everything else is on the other. Implicit functions, however, have x's and y's combined. So, for example, x times y equals 3 sine x, or x squared plus y squared equals 1. So implicit functions allow us to blend our x's and y's together. We know how to take the derivatives of explicit functions. In this video, we'll learn how to take the derivatives of implicit functions. Let's start by looking at an example. We have x plus y equals y squared. I'm going to start by taking d by dx of both sides. So if I take d by dx of x, it's just dx over dx. If I take d by dx of y, it becomes dy by dx. And I'm going to leave the right-hand side as just d by dx of y squared. Dx by dx is the same thing as 1. So on the left-hand side, I'm going to have 1 plus dy by dx. And remember, dy by dx is the derivative. So ultimately, we're going to want to solve for dy by dx. On the right-hand side, however, we're going to have to use the chain rule. Notice that the inside function is the y, and the outside function is the squared. So we're going to first do the squaring, just like we would, leaving the y alone. So I'm going to have 2y times the derivative of the inside function, which is dy by dx. So now we solve for dy by dx. I'm going to move all the dy by dx's to the same side of the equation and move everything else to the other side. Factor out a dy by dx from every term on the left and divide both sides by the remaining to get dy by dx by itself. So the derivative ends up being negative 1 over 1 minus 2y. Let's try another example. Let's look at the function xy equals sine y. d by dx of xy will then equal d by dx of sine y. And the left-hand side, we're going to have to use the product rule. So we're going to do the derivative of the first, leave the second alone, plus leave the first alone, take the derivative of the second. The right-hand side, we're going to have to use the chain rule. The derivative of the outside, leave the inside the same, times the derivative of the inside. The derivative of the inside, remember, is dy by dx. So now we simplify. Dx by dx is just equal to 1. And we get all the dy by dx's on the same side of the equation. Factor out to get dy by dx by itself, and then divide both sides by the remaining. So the derivative is going to be negative y over x minus cosine y. To find the slope of the tangent line at a point, we can use this derivative and just plug in the x and y value. So let's find the slope of the tangent line at 2 over pi comma pi over 2. We're going to use our dy by dx. X is going to be 2 over pi, and y is going to be pi over 2. So dy by dx equals negative pi over 2 over 2 over pi minus cosine of pi over 2. So cosine of pi over 2, remember, is 0. So we're left with negative pi over 2 over 2 over pi, which simplifies to negative pi squared over 4. So the slope of the tangent line to xy equals sine y at the point pi over 2, or 2 over pi comma pi over 2 equals negative pi squared over 4. Let's do another example. x squared plus y squared equals 1. Remember, this is the equation of a circle centered at the origin of radius 1. We take d by dx of both sides. D by dx of x squared is just 2x. D by dx of y squared is a chain rule again, 2y, so that's the derivative of the squaring, leave the inside the same, times the derivative of y, which is dy by dx. The derivative of 1 is just 0. So 2y dy by dx equals negative 2x. I just moved the 2x to the other side of the equation. So dy by dx equals negative 2x divided by 2y. We can cancel out the 2's and we're left with negative x over y. To find the second derivative, we're going to apply d by dx to the derivative we've already found. And in order to do that, we have to use the quotient rule. So low, that's y, d high, negative 1, minus high, negative x, d low, that's going to be dy by dx, square the bottom, so that's y squared, and away we go. We can simplify that to negative y plus x, and instead of dy by dx, I have negative x over y, all divided by y squared. So I end up with negative y minus x squared over y, all over y squared. That's the second derivative. And we can simplify it if we desire. And we end up with negative 1 over y cubed.